For our fifth example of a titrated med, I'm just going to get you started and then I will share the answers with you if you want to check your work when you're working on this on your own. So in order to get you started with this, in the problem, I read that the order is from 0.5 to 7 micrograms per kilogram per minute, and we're measuring their blood pressure. I see that my patient is 6'1" and that they weigh 236 pounds. I did note that when I read the order, it was per kilogram. So the first step of math that I'm going to do is take 236, divide by 2.2, and I get 107.3 kilograms. So divide by 2.2 equals 107.3 kilograms. I do need the patient weight because of the kilograms in the order. Continuing to read, I see this 50 milligrams in 250 mLs. So that is the strength of my med. And that is one of the things that I am going to need to do my dimensional analysis. The first question that I'm asked is for the minimum. And so I look at the range that was ordered, and I'm going to start with 0.5. Micrograms goes on the top of this fraction, and both kilograms and minutes go in the denominator. So I need to get this to be milliliters per hour. First thing I'm going to do is, because the kilograms are involved, I will multiply by the 107.3 kilograms and cancel that out. I put that over a placeholder 1 because that was not a ratio to begin with. Micrograms are going to need to change into milligrams because of what's in the IV bag. So I know that that is 1,000 micrograms to 1 milligram. And then I can use the IV bag itself. So 50 milligrams is going to go in the denominator because of needing to cancel milligrams. And that goes with 250 milliliters because they're in the same IV bag. Milliliters is something I want, so I'm circling that. And that sends me back to the beginning. I have minutes in the beginning, and I need those minutes to cancel and turn into hours. So on the top, 60 minutes, on the bottom, 1 hour, and that takes care of all of the conversions that are needed to have milliliters per hour. So to do my math, I'm going to multiply straight across the top. So 0.5 times 107.3 times 250 times 60. And that gives me a large number, so I'm going to jot that down, 804750. I multiply across the bottom, and so across the bottom I get a 5 with 1, 2, 3, 4 zeros with it. And so then I'll divide that out. And I come up with 16.095. Because this is an IV rate, it should be rounded to tenths, so that rounds to 16.1 milliliters per hour. So this is my minimum. Now from here forward in this entire problem, I'm going to switch to using a proportion because it's going to be a shortcut to setting up all of that dimensional analysis. So I want to set up my proportion dose over rate. So I'm noting that this is my minimum dose. So I will be using that every single time. And over here, the 16.1 is my minimum rate, and I will be using that every single time. And one of the things that you might notice as you go through this problem is that doing dimensional analysis will yield a slightly different answer than doing the proportion when we're dealing with the maximum. And that is because there is this little bit of rounding that we had at the very end of this. And so that makes a difference when we're looking at the maximum. So you will get a different answer if you use the proportion versus the dimensional analysis. In a test situation, I will accept both answers as correct, and so either one is fine. In the MyLab situation, you're going to be prompted that you must use the proportion. So I'm going to set up the proportion. The proportion is always dose over rate. And so my minimum dose is 0.5. My minimum rate is 16.1. My maximum dose is up here in this range. And so the 0.5 is the same label as 7. And I don't know what that maximum milliliter per hour rate is. So I will cross multiply. I get 0.5x is equal to 16.1 times 7, which is 112.7. And then I divide by 0.5. And so I have 225.4. And that's milliliters per hour. And so that number, it's all squeezed in there, is the maximum. Now I get to move to the chart. And so for the entire chart, I am going to be setting up dose over rate. And for the entire chart, I am going to be using that minimum dose of 0.5, which produced a rate of 16.1. And then I'm going to be filling in the number they give me at an appropriate spot. So in this first chart, I see that they're giving me the rate. I know that the rate goes on the denominator, so I would put the rate down here and put the x in the numerator. So I'll solve this first one. I multiply diagonally and I get 16.1x. And I take 0.5 times 30, which gives me 15. And then I'll divide both sides by 16.1. And so my x, let me show my work, divide by 16.1. My x will equal 0.93, etc. And we're going to round to tenths. That was in our pre-lecture, so 0.9 micrograms per kilogram per minute. I would set up the remainder of this chart in the same manner. So to set up the second one, I put dose over rate. I put 0.5 over 16.1. I put my 45 in the denominator because it is a rate, and I put an X on the top to figure out a dose. And I'll show answers at the end of the video, so if you just need to check your work, you can skip ahead. If you're needing to learn how to do this problem, we'll take a look at the second chart and how to set that up before I show you the answers. So in this chart, again, I will do dose over rate. That is my method for everything. Again, I will use the 0.5 over the 16.1 because that is the minimum that I'm using throughout this entire problem. Now, in this chart, I am given the dose value. The dose is the top of my proportion, so I'm going to put the 2 on the top of the proportion and put an X in the denominator. So to solve, I'm going to use cross product. So multiplying diagonally, I get 0.5x is equal to, and on this diagonal, I take 16.1 times 2, which is 32.2. Then I divide by 0.5 on both sides. And I get an answer of 64.4 milliliters per hour. I do the rest of this chart in the same way. So the next one, I would put dose over rate. I would put 0.5 over 16.1. The 2.2 is a dose, so it goes on the top, X goes on the bottom, and I'll let you to solve it out and finish the problems on the screen. So once you have everything done, pause the video for now, finish it out, and then you can unpause the video and the answers will be next. So here are the answers. You see both the minimum and the maximum that I showed you how to find. You see this answer of 0.9 and then you should get the remaining ones in bold. For that first chart, you see the answer of 64.4, which we worked out, and then you see the answers in bold for the remainder of the second chart.